might as well record this because folks aren't here. So no one knows. So I'm going to go with the assumption that it's just business as usual, and third hour is just going to have to watch this video because they're going to be robbed of their opportunity to sit through this. So, but they can, you know, that's the power of technology. They can watch this this video. I don't know if they will, but they certainly could. I haven't done this practice quiz yet, but I mean, I have an answer key, so I haven't actually worked the problem. So this will be my first time too. So I assume you got it done and that you're now eagerly awaiting the results to see how you did. So if not, you'll get less out of this than someone who did. That's just the way that cookie crumbles. So this is practice quiz number 2. And then for problem number 1, I knew that. I knew that. I was just testing you. You guys all watched the Avalanche get their big overtime win in game 1 against the Blues last night? It's a little nerve-wracking there for a while. Yeah, okay, practice quiz number 2. Oop, I covered it up. Problem number 1. Because the denominators are the same, I would just add the tops together. So 5x minus 2x makes 3x. And then I would put that over 12x squared, bless you. And then I would simplify because, well, I can. And so because everything's attached by times, everything that we see by definition is what we call a factor. And factors are things that can be canceled out. So this 3 and this 12 can reduce to a 1 and a 4. And this x and this x to the second can reduce in the sense that the x on top goes bye-bye and the x on bottom is 1 less. And so we wind up with nothing on top. So we need a 1 as a placeholder over whatever's left on bottom, which is 4x. Done. All right. Bless you. Problem number 2. I again find myself with common denominators, so I'm just going to simply add the tops together. And when I take the tops, I have n plus 6 minus 4. 6 minus 4 is 2. So I wind up on top with n and then a positive or a plus 2. And I'm going to put that all over the common denominator, which I do want to factor, just in case. I don't know. But going into this, if it says n squared minus 2n minus 8, I think what could be the harm in factoring this, right? So obviously the bottom is n plus 2 times.
Be quiet in there.
Could you just shut the door? I don't want to deal with that. Thanks. It always is. So the bottom factors into n plus 2 times n minus 4. And then what happens is we go, oh man, I'm really glad I factored because the n plus 2 just happens to kill the n plus 2. Sometimes it'll happen, as you've seen, sometimes it won't. But we've had fruitful searches in both of our first 2 problems and that things canceled out. So again, with nothing left in the top, we need to put a 1. So our final answer is just 1 over n minus 4. Okay. For number 3, I do not see that there is a common denominator. And so I need to now go big brain mode and think about what is the least common of the denominators. And since there's a 5 and an n as factors of the left, and only one factor on the right named n minus 5, then my least common needs to consist of a 5 and an n minus 5. So that's going to be the big brain step that gets you over the hump. If you can find a common denominator, the rest of this is literally just mechanics. There's nothing to get or not get. It's just following steps at this point. So now I'm going to take the first fraction, and his top is 3, and his bottom needs the n minus 5. So I'm going to take the 3 on top and multiply him by what the bottom needs. And then I'm going to go to the second fraction, and his top is negative. And how you want to do this is completely up to you. I think what I'd probably do in a case like this is leave the negative out for a minute and just think of the top as 6n plus 6. I think it'll make this process a little less gummy. And so if I just think of the top as 6n plus 6, the parentheses serve a purpose here of reminding me that I got to distribute that minus sign through, but I'm going to hold off on that. And so I'm just going to think of it as minus the top, and then the top needs the 5 in the n. And so I'm going to multiply the top by 5n. All right. And then it's just, distribution, combining like terms from here. So if it helps you guys, if it makes you feel, some people feel more comfortable if I do it this way, you could put the 5n over on the left-hand side, we tend to feel better about distribution when it comes in from the left side. It's just kind of how we've been mathematically brought up. So it doesn't matter where you put it, but that's what you're distributing. And so on the left side, you wind up with 3n and a minus 15. And then when you work out this right side, you get a minus 30n squared and minus 30n. And as you've seen me doing the last couple days, I just don't worry about the bottom right now. I don't see the sense in continuously writing over 5n times n minus 5 over and over. You know, what's the point? I'll come back to that when I'm done with the top and darn good and ready. So my top, I feel inclined to want to write it in a nice proper format. And so I'm going to put my minus or my negative 30n squared first. I'm going to sum my n's together. 3 minus 30 is negative 27 of those. And then my constant term is minus 15. And at this point, it would probably be appropriate then to reintroduce the denominator and say, okay, so this is all over 5n times n minus 5. So if I were to say, are we done? The answer to the question is not sure, right? Like maybe not, maybe not, I don't know. But the only way to really find out, as you know by now, is to factor anything that can be factored. Bottom can obviously not be factored. That's as factored by definition as something can get. But the top, I got some work I could do up there on the top. I could take I could take a negative 3 out. I certainly can't take out a 5, right? 27 is kind of a deal breaker there. But I could pull a negative 3, which would leave me with a positive 10 and an n squared and a plus and a 9 and an n and then a plus and a 5. As you know, pulling negatives requires all signs to change. And this will turn out to be a fruitless search. Like this is one of these times where we factor a little bit and realize, oh, well, I couldn't do anything anyways, but what's the harm? It takes like 9 seconds to figure it out. And obviously I can't factor this thing that I'm underlining because 10 times 5 makes 50. And there are no numbers that multiply to make 50 and add to make 9. Like that isn't happening. So having said that, this would be a perfectly satisfactory final answer. Some people like to multiply the bottom back out. It's like, okay, if you want to. There's not any punishment or reward either way. So the idea is we're just taking a look at things and killing in anything we can. All right. Question number 4. Again, the idea is what are the denominators? And you can go a couple different pathways with this. If you want to take a really robotic approach to this, which I've got no issues with, you could just do it as it is. No worries, no harm, no foul. So I could look at this and say, I know that the least common denominator is I need one of these, and I need one of these. Nothing wrong with this at all. There'll be a little factoring and cleanup that inevitably we'll have to do at the end. That's okay. And so if I think of that as my least common denominator, then I simply, again, take the same approach and focus on the tops. The first fraction has a top of 4n. And then I look down at the bottom of the fraction and I say, okay, you've got n plus 6. You need 2n plus 2. So just how this works, that's what gets you through this quiz. And then you look at the second fraction and say, you have a top of negative 2n. And your bottom is missing the n plus 6. So I'll give that to the top. All the while I'm doing this, I'm multiplying to the bottom. So I'm just not showing it. Like, what's the point? And so much like problem from number 3, we just work out the top. Let's just do the top. Do your 8th grade distribution, combine like terms, and then let's see where it takes us. Who knows? So we wind up with 8n squared plus 8n minus 2n squared minus 12n. Still not done. I'm going to work it out. 8n squareds minus 2n squareds is 6n squareds. 8n's minus 12n's is minus 4n's. And at this point, again, it would be appropriate to introduce the denominator just to see what we're at. And what is your inclination here? Are we done or are we not done? Yeah, we're not done. And this time, our search will not be fruitless. There's a 2 that we could have plucked out 4 minutes ago. It's okay. We can pluck it out now. Your math spidey sense just tingles and tells you, look at that top. I can pull out a 2. Nice. So if I rewrite the top, it is 2 times 3n squared minus 2n. And if you're asking the question in your mind, hey, Mr. Ahern, why didn't you pull out a 2n? That question will be answered in about 35 seconds, okay? Just pulled out what I knew I was going to need. And then I go digging through the bottom and ask myself, boy, I wonder if I can find any 2's down there that I could cancel that free 2 on top with. And of course, the answer is, I found you. You're right there. You're hiding in that second factor. And of course, that second factor, you can pull out the 2. And so what winds up happening is the 2 that I pull from this comes into the front. And then the 2n plus 2 renames himself now. He's a divided by 2 version of his former self. And so instead of 2n plus 2, he's 1n plus 1. So you can find those common factors anywhere, but here you got to get in and dig them out. And then you go, I got you now. I got you 2's, your factors, I can cancel you. And then what's left and not crossed out is, of course, the final answer. So if you were going to, again, ask the question of why didn't you pull out the GCF at the top, my answer is because I didn't need it. It wasn't going to do me any good. Good? Right then. That takes us to question 5. Question 5 is just kind of, again, this is just really, in case you're interested, by the way, going back to problem 4, I don't really want to rework the whole problem, but just in case you're interested. That fraction on the right of problem 4 said this. And if you're interested in getting your common factors out earlier, like we did yesterday, you can take the top, think of it as 2n, and the bottom, and think of it as 2 times n plus 1. And then you can actually fish that common factor of 2 out before you begin the problem. I hope that makes sense. And then from there, you would proceed like we did yesterday with 5 and 6, and you can work the problem with the second fraction, having a new identity. Either way, the 2 is going to pop out eventually. It's got to. Hope that makes sense. And so, Mike, I guess why I'm saying that is on number 5, look at the fraction on the right. What do you notice? Everything in there is divisible by 2, right? And so if I think of the top of number 5 as just a 4, and then if I think of the bottom as 2 times 3m plus 3, and I mean, if this kind of stuff confuses you, I don't know if this will confuse you more, but if you think of the top maybe more specifically as 2 times 2, then it becomes very visually apparent that, oh, look, there's a 2 and a 2. And so you could basically start the problem from this point with your second fraction just being a simplified version of himself. And I'll go ahead and do that one this way since I'm recording this and I didn't do the other one this way. So what the heck, we'll get a little bit of each. So my problem that I actually see on number 5 now is 6 over 5m minus 4 plus 2 over 3m plus 3. And if you're interested in that bottom right and saying, well, can't we factor out a 3? Sure, I just don't, there's really literally no benefit at this point to doing that. So I'm going to leave it like it is and proceed. So what is our least common denominator, having worked it like this? I need one of these, and I need one of these. So the line of questioning for the 74th time is, what does the bottom need? I'll give it to the top. What does the bottom need? I'll give it over and over and over and over again. So for the first fraction, what does the bottom of it need? 3m. Right, so I'm going to take what was on his top, the 6, and I'm going to multiply him by what the bottom would have needed, which is 3m plus 3. And then I'm going to take the second fraction, which has a top of plus 2 or positive 2. And again, I say, what does the bottom not have? Well, this. If the bottom needs it, we multiply it to the top. Any questions on that? And again, just pure mechanics, right? Distribute, don't mess up negatives and distribution and combining like terms. So we get 18m plus 18 plus 10m minus 8. And then we put it all together and we wind up with 28m plus 10 over 5m minus 4 times 3m plus 3. I asked this question because I just want to start hearing you answer it correctly. Are we done? Right, no. The answer actually, potentially for the record, is I'm not sure. So to say no means I'm committed. I've already factored this and I'm sure that I'm done. And so the answer really that we're going for is I don't know. And that's okay to say that because the top clearly can be factored and the bottom, there's a little bit of factoring I can do. And the question is it going to be a fruitless search or not? I don't know. That's the answer we're going for. Just not sure. So if I take the top, the best I could do is pull out what, a 2, and I'm left with 2 times 14m's plus 5. Okay, that was cool. And then the bottom, do you see the factoring that I'm talking about? Right, factors on their own can be subsequently factored. This 3m plus 3 can be divided GCF'd by 3. And so I could pull the 3 out front. You saw me do this 5 minutes ago, and then I can rewrite 3m plus 3 as m plus 1. And so in its like final factored state, the problem looks like this. That's the best we're going to do. The question becomes, okay, here are I have 5 factors on the television, a 2, parentheses, a 3, parentheses, parentheses. The question becomes now, do any of them kill any of them? Nah. So when I go back in time and I had asked the question, are we done? Now we know in hindsight that the answer was yes. We just didn't know at the time. Yes, Sam?
Now you pull the 3 out, put it in front.
I do.
How can you attach to
Because multiplication possesses a property that we call, it's got a commutative property. I don't think we teach a lot of that anymore these days. But basically, would you agree that 3 times A times B is the same as like A times 3 times B? Or that it's the same as B times A times 3 or B times 3 times A? I could do this all day, right? The point is, I just put it out in front because I like it there. I like my GCF, my numerical GCFs to just always like get filtered out to the front. Does that make sense?
Yeah.
So it doesn't apply itself necessarily to the 5m minus 4. It applies itself to the bottom. I just choose to put it out front. That's not a bad question at all. I would be inclined to want to know the same thing. Put it wherever you want. I just like it out front. Okay. So going back in time, you can leave your answer like this. As I've said before, if you're going to take the time to factor it, to run the check, why not just submit it that way? I don't really care. But you could also go back then and submit your answer as what it was before you ran your fruitless search. Me, no care. All right. That leads us then to problem number 6. And 6, we're faced again with the idea of what is a common denominator. And so a couple of things about this, you could, like I said on problem 3, no, problem 4, you just dive right in, just go. Or what do you notice about the fractions? Say again. Yeah, the fraction on the left. Yeah, so what can 6 and 3 go down to? Sure, so again, if I think about just attacking individual fractions, why not make the number smaller? So the first fraction becomes a 2 over 1. Not 2 over 1, because you know you're going to want it as a fraction. So just leave it. And then the fraction on the right, if I think of the top as 2 times 3b, and then I think of the bottom as 2 times b minus 2, what I've done is I've exposed a commonality. And the 2 on top and the 2 on bottom can go, and I'm left now with a simpler version of the problem of 2 over 1 plus 3b over b minus 2. It's a nice little trick to be able to do that. All right, small brain question. What's the least common denominator? B minus 2. So if the least common is b minus 2, I simply say, well, first fraction had a 2 on top. Its bottom needs b minus 2. Second fraction had a 3b on top. Its bottom needs nothing. So then I perform a little bit of 7th grade distribution. 2 times b is 2b. 2b plus 3b is 5b. 2 times negative 2 is negative 4. 5b minus 4, b minus 2, done. And this time, if I say, are we done? You could say, yeah. It's not an I'm not sure. We're sure. It's factored. Nothing goes. We're done. And if you try to cancel that 4 and that 2, as I've said many, many times, it's going to be a real long day for you. Right? Or the b's. Right, they're parts of things. You get that by now, I think. Number 7, right out of the gate, there's really no cleanup work that we could even do. So this is just a you take it as you get it kind of thing. What is the least common denominator? Only if you want a kitten to die. Why can't you cancel? Listen, I will keep going. I don't mind. It is, and I don't disagree with what you're saying, but on a grander scale, it's part of a subtraction problem. And that question you can ask, and I will never get upset, because that would be, to me as a student, my biggest blocking point. I get it. I feel your pain on that. Like, you look at the 5 and go, it's part of a multiplication, but Royce, really, it's not. It's part of something minus 2. For that reason, or did I say, yeah, minus 2. The minus 2 makes it off limits. If I wanted to be able to cancel the 5, Royce, the bottom would have to say something like 5 times, and then in parentheses, b minus 2. And then the bottom is just literally one big multiplication problem.
What if it was like the first fraction plus second fraction?
Here's what I need to try to get stuck in your head. Royce, that is not part of a multiplication problem. It is part of a subtraction problem.
Why did we cancel the on the last problem?
Mhm.
6. Because it had a b in it. There's a 6 had a b in it. Okay, I see.
I can't see. I must have erased something, but are you good?
Yeah.
Are you sure?
Yeah, but if the top 5 had a b in it.
No.
What? That makes no sense.
Well, I'm sorry, and I'll talk about it more, but let's not. Listen, I'm going to try to explain this, but what I need you to do is go into it, not with the mindset of I don't get this, but rather with the mindset of I want to get this. So going back to the last problem, I understand your concern, but I need you to be clear. And there's a reason I do things the way that I do them. Looking back, I shouldn't have erased this, but I did. I did not do this. If I did, I would fire myself. I would go to the office and I would say, I need to be removed from my post. I'm giving you this as a courtesy. You've got approximately 2.5 months to find my replacement. I'm no longer qualified to teach high school mathematics. You understand that? Yeah. I would never in a million years cancel the 6 and the 2. Ever. Like I said, unless I was having some sort of issue that caused me to not then be able to function. So I need you to go back and look at what you wrote down, because I wrote it down and I know you did too. I wrote the top as 2 times 3b. I'm certain that I did. Yeah. And then on the bottom, I wrote it. What is this called? What kind of problem is that? I just put a bubble around it. What is that called? It's called subtraction, and it is off flipping limits. Okay. I'm not trying to condescend you. I'm telling you that is called a subtraction problem. And then I did something called factoring. The reason we learn to factor is because factoring turns addition and subtraction problems into multiplication problems. The bottom is not a multiplication problem. However, it can be written as a multiplication problem of 2 times the quantity of b minus 2. The top is now 2 times something, and the entirety of the bottom is now 2 times something, which at this point now renders these 2's its open season. Do you understand that? Yeah. Like for real? Yeah. I would have the exact same mental block if I were you. But it must be a multiplication problem. By definition, it must consist of what we call factors for things to be cancelable. Got it? So again, to be clear, on number 6, I did not cancel the 6 and the 2. Okay, good. So going back, zip it to problem number 7. Let me ask you this, Royce. Can you write the bottom as a multiplication problem? I don't think so either, because if I try to pull that 5 out of the bottom, I'm left with 5 times b minus 2/5. And ain't nobody got time for that, right? So because I can't factor the bottom, I can't turn it into a multiplication problem. Those 5s are off limits. Now, I'm going to take the least common denominator on number 7, which is one of these times one of these. And I'm simply then going to ask myself, what does each fraction need? The top of the first fraction is 2. His bottom needs the 5b minus 2. Consider it done. And then the second fraction has a top of negative 5. His bottom needs the b minus 1, so I shall give it to the top. And as is generally the case, this portion of the problem is very simple, basic mechanical mathematics. I just distribute, combine like terms, and hope I don't do anything dumb. We all make mistakes, right? So 2 times 10, or 2 times 5b is 10b. And then 2 times negative 2 is negative 4. And then we have minus 5b, and then, of course, plus 5. Combine it up, and let's just see what happens. Who knows what's coming? So 10b's minus 5b's makes 5b's. Nice. And negative 4 plus 5 makes positive 1. And then again, it's always it's appropriate now to introduce your denominator. Bring it in. It is now fully factored. Can anything cancel? Oh. What would you be inclined to want to cancel? The 5b is a part of an addition problem. So I get your inclination. I don't for a second. Like when kids can't understand why negative 4 minus 3 is negative 7 and not negative 1, I never have understood that. I struggle with that. I struggle with how lazy is a kid to not just say, I'm at negative 4 on the number line and I go down. How can you not get that that's negative 7? That one makes me mad. Not getting that, though, doesn't make me mad because it's hard. But if it's part of an addition problem or a subtraction problem, we don't touch it. So this is done. Okay. Number 8. Number 8 has a similar, Royce, I'd maybe appreciate this. Maybe you're done talking to me. I don't know, but is there anything that can cancel on number 8 on that second fraction? Good. Could I factor the bottom? Yes, I could. Look, I could turn the bottom into a multiplication problem, meaning, so you're saying there's a chance. If I take the bottom of number 8, the second fraction, I could write it as 5 times x plus 1. But then I look at the top and I go, snap. There's no 5s. There's no x plus 1s. So no benefit. Fraction on the left. Anything cancel? God, no. So this is one where we just say I'm going in. So I'd look at the least common denominator is one of these times one of these. And I'm going in. Second verse, same as the first. I look at the first fraction and say your bottom is missing the 5x plus 5. So your top, having been 3x, I shall multiply into you what your bottom did not have. Second fraction has a top of negative 3x. Bottom needs the x plus 3, so I shall multiply it to the top. And for like the 5th time today, we're just going to work out the top and just see where the day takes us. So we wind up with 15x squareds plus 15 regular x's minus 3x squareds minus 9 regular x's. Combine your like terms and you're left with 12 of those x squareds plus 6 of the regular x's. And it's appropriate now to introduce the denominator This is just screaming at me. Factor me. Maybe there's hope. So what could I do to the top? You could pull out a 6, actually, would probably be preferred. And quite frankly, to make this really look the way we want, you could even pull out a 6x. Because if I'm thinking about what's going to be in these parentheses, those empty white parentheses, I'd like it to have a shot to look like the ones on the bottom. And if I only pull out a 6, it's going to be left as 2x squared. Well, that ain't working. So if I pull out a 6x in this case, I've got a shot. And I'm left then with 2 x's and plus 1. So there is numerator, new and improved version 2.0. Can I factor anything on the bottom? Yeah, this factor is yelling at you. Look at me. I have something to give you. I have something for you. I have a 5. And so back to Sam's question from like 9 minutes ago, I can take the 5 out of that second factor and throw it anywhere. I like the front. And so, and then I take this 5x plus 5 and knock it down to the shrunken version of itself, which is now x plus 1. And this is it. We can't factor any more than this. We look at it. Is anyone killing anyone? No. So it was a fruitless search. And as I said, leave it like that if you want, or revert back to its pre-factored state. Doesn't matter. Question number 9 is 4 minus x squared over what? X plus 3, x minus 3. Very good. Anytime you see a difference of squares like that, not the one on top, but when we're talking denominators, there's 100.0% chance someone wants you to factor that thing out. And then the second fraction is minus x minus 2. And if you still are not wise to this trick, I honestly have to venture a guess that you just literally haven't been here. What do you notice? He's backwards, and what do you want to, how you going to flip it? So I'm going to take that 3 minus x, I'll be with you in just 1 sec there, Nussbaum, and I'm going to write it as x minus 3. And of course, the fee that I pay for that little convenience is I move the negative to right there. What's up? Because I'm not worried about the tops. I get your point, but what you learn about this over time is the top is just along for the ride. The top, if you want to switch it, you can, but at this point, the tops mean absolutely nothing to me. It's all, if you haven't gotten this memo, get this. Make the bottoms the same. This entire quiz, your grade is based on that one concept, make the bottoms the same. What happens with the tops is just like a collateral sort of damage thing, like whatever, right? Okay. And now I'm ready to start the problem. That was all just cutting the vegetables. Now we got to cook the dinner. And so what is the least common denominator? I need one of those and I need one of those. So I look at the first fraction for the 27th time and ask the question, what does its bottom need? Nothing. So 4 minus x squared, you are untouched. And then the top of the second fraction is plus x minus 2. I'm parenthesizing that because you know and I know that it's about to get multiplied by something. What does its bottom need? So I shall give it. There you go. Now you happy? You got what you needed. And then we mechanically just grind our way through the top and see what happens. So the 4 minus x squared is like, okay, come along for the ride. And then we wind up with plus x squared plus 1x minus 6. That's just that multiplication of those two binomials. And like I said, the top will do what the top wants to do. The top is literally just along for the ride. The bottom is where it's at. So now I'm just kind of at the mercy of the math gods. And I go, oh, thanks, math gods. Minus x squared and plus x squared. Thanks, dudes. And then the top also cleans up then to be x minus 2. And then at this point, as I've said before, it's appropriate to introduce the common denominator, and the common denominator was x plus 3 times x minus 3. So the question is, are we done? In this case, we can say yes. There is no exploration necessary. Anything is dead to rights. It's all factored out and can't be any more obvious than that. Number 10, we are cooking right along here. I have x squared. Oh, the bottoms are the same. Never mind then. Whatever speech I was about to prepare, I'll save it. If the bottoms are already the same, then we can just put the tops together. That is awesome. So we wind up just with x squared plus 3x minus 4. And then we put it over the least common denominator, which is, why do I call it that? Like the denominator, it's the only flipping denominator. And the denominator is x plus 6 times x minus 1. Any questions about that? Are we done? Haha, good job, Sammy. No, factor that dang top. Will it be fruitless? I don't know. Let's find out. And so the top factors into x plus 4 times x minus 1. And then the bottom is still x plus 6 times x minus 1. And jackpot. We cancel. There's your final answer. Number 11, we're back to that idea of the denominators are, am I going too fast? I see some people trying to get my work down. So the tops are what I'm gonna add together because the bottoms are already the same. So I just do 9x squared minus 16. That's pretty unexciting. And then I put it over 6x minus 8. I lovingly crafted this problem, and I intend to do the same with all the versions of this I get to write tonight. And I will lovingly craft some problems I'll let the computer do, but some I like to craft with intentions. And this one was from me to you. Are we done? No. What is the top? It's got a name. It's called a difference of two squares, and it's like the 1984th one that you've seen. Something squared minus something squared by definition can and should always be factored into square root plus square root times square root minus square root. That's the top. And you might say, well, whoop-de-doo there, big guy. Well, what about the bottom? You can pull out a 2, and it is not a fruitless endeavor because all of that effort and knowledge led to the conclusion that, hey, I got a factor I can kill. And so cancel, and your final answer is up there on the board. Hey, Royce, can I cancel out that 4 and that 2?
No.
Heck no. Right. Last problem is number 12, I suppose. And I guess I'll just copy it up here. So I have x minus 2 over x minus 3 minus, and again, don't focus on the top and thinking, oh, I should factor the top. That's appropriate later on if it happens at the end. But for now, it's just a bunch of junk. X squared plus 4x minus 11, and then it's all over x plus 7x minus 3. So our thinking at this point is, what's the LCD? What is it? Yeah, good job. I need one of each. X plus 7, I need one of those, bless you, and I need one of those. And so I simply say to each fraction, what do you need? I got you. Whatever you need, I'll multiply it into your top and your bottom. I'm not breaking any rules here. What does the first fraction need? Yes, and so I multiply it, and I'll just show my work this time. I know sometimes I don't. It just feels more, I don't know, correct to show different work on a problem like this to me. So I multiply the bottom by x plus 7, and then in turn I say, well, fair is fair. I better turn around and also multiply by the top. And as is generally going to be the case, it's this that we're worried about. The math problem exists within this green cloud. The math problem is all the basic pre-algebra and algebra 1 mechanical crap on the top. And then when we're good and ready and we're sure we've distributed correctly and combined like terms, and then we're going to put it back over the LCD and see what happens. So the top of the left fraction is x squared plus 5x minus 14. And this will really be, I think, if you generally know what you're doing, this topic here will be the difference between like a 98% and like a 90% is, do you know what's coming? And it's going to be minus x squared minus 4x and plus 11. Did you all catch that? That's really going to be, I say, a deciding factor is, are you one of these people that recognizes that that minus that I'm circling obnoxiously is a distributable negative and it needs to distribute to the entire fraction that is after it? All right, one crisis averted, and now we're going to go, let's see. Hey, math gods are so nice. X squared and minus x squared cancel out. And then, of course, 5x's minus 4x's makes 1x, and negative 14 plus 11 makes negative 3. And again, it's appropriate to introduce the LCD, which is a plus 7 and a minus 3. So what's our final answer? Nice. 1 over x plus 7. Done. Got it?